What's up, guys? This is another bi-weekly contest on LeetCode, and hopefully this one will go like much better than some of and the three previous contests that I had on Code Forces. With odd sum, this is just you taking the counts modulo like 2 or something. Answer equal to 0, and then that's the modulo. Update sum with the element. Take the mod 2 and then so want an odd sum, that means we switch the bit. And then lastly, we add this into the map. Use example test cases, run code. Turn count of odd numbers between low and high. So turns count of odd numbers less than x. So turn x by 2. I can decompose the range into like these two. 4, 0, 16, 4, 1. This looks good. 3 and 1. This also looks good. This was called good if you can split. Number of distinct letters in P and Q are the same. Let's like calculate for each prefix and for each suffix. 2 non-empty strings, okay? The number of distinct letters when we split them. Accepted. Submitted too soon. Left I plus right I. I think this works. Does it? Wait. Yeah, okay, I think it does. And then in order to calculate these, need a set to store the number of distinct elements. I plus 1 is equal to the size of the set. And we insert the character into the set. We do the same thing for each of the suffixes. Accepted. 2, 1, 4, 2. Choose any subarray and increment each value by 1. Oh wait, no. Okay, if Ly is equal to Ri, then we add 1 to the answer. That's what we're looking for. What we do is we find 2142, okay. Find the minimum and then we increase it until the minimum. Accepted. So if we're in this like range, everything here has been like set to 2. So let's calculate the left array and the right array. So the next left like smallest and next left biggest. Just replace target with T so it's easier to write. Also, the value at the left is greater than the current value. Then we just do this. (32 bits signed integer). How much do we add? So the current value minus what? The maximum of the one on the left and the wrong one on the right. Okay. Run code. So 3471. Okay, let's hope this is correct. I think it's correct. Accepted. Cool. So that took me like almost 8 minutes. 7 minutes and like 50 seconds. Don't know if I'm first or not. Oh yeah. So I have to wait until like, okay, I have to wait for 2 more minutes to actually see the ranking. I think I could have been a bit faster with 4. Okay, anyways, like, I'll try to explain my algorithm. So, what my algorithm attempts to simulate is a greedy algorithm. So, the way the greedy algorithm works is, let's say it's trying to solve for this array. When you should greedily, like, let's say the minimum value is x. Then you should increase all of the, like, each value in the array by x. And you use x operations for this. And after you've done so, like, this element will be good. But then these two, like, the subarray on the left and the subarray on the right will be like bad. So you run the like use recursion to run the function for the subarray on the left and the subarray on the right. And you basically just keep doing this until like you've basically reduced each subarray to a single element. So that's the basic like algorithm. But however, like if you do it directly like this, it might be slow. So you need to be able to find the minimum of a range in like constant time or log n time. and you need like range minimum query for that, which is like, it's not slow, it doesn't run slow, it's just a bit slower to write. So what I did was I used the standard stack algorithm to find. So let's say that minimum here is y, then what you could do is you can use the standard stack algorithm to find, like, for each element, the first element to its left, which is the first element to its left, which is smaller than it, and the first element to the right, which is smaller than it, which is smaller. Now you can basically get the range for which, like, this element is the minimum. And you can also get the value of the element, the value of, like, the element before, like, before we change it to x, and that value is precisely the maximum of the left one and the right one. So then you just add the final value minus the initial value. Yeah, maybe this made a bit of sense, but oh, this is a really easy contest, so I'm not sure if I overkilled this. Maybe there's a stack. Actually, you would still have to use stack somehow. Maybe there's some way you can use stack to, like, go from, like, just do a sweep from left to right. But like 3 minutes, that's like really fast. Wait, 5 minutes. You know, I got the first two in 2 minutes, and then so that was like about average. First two in 2 minutes, and then I don't know what happened for problem 3. There might have been an easier way to do this. And then I hesitated a bit for problem 4. I'm not sure if there's an easier way for, like, problem 3 and problem 4, but then that's ultimately what made me a bit slower. But I think, like, third is still good. Like, yeah, third is still pretty good. I'm very glad that, like, I didn't get any bugs and stuff. So hopefully you found this interesting, or you learned from it maybe. And yeah, I'll see you in the next video.